Kau buat lah.
Tadi tak ada orang join, so aku buat dulu.
Oh, kau buka lagu lah. Okay.
So kita,
Faham.
aku akan buat live terus. Nanti kita terus lah.
Okay. 10 lah.
Oh, 10 lah. Ya, sekarang baru 10. Okay.
10 minit lagi. Aku boleh pula apa? 5 minit sebelum ni aku sakit perut pula. Kejar aku kita nas.
Tu aku tengok macam, orang lain tak join lagi. Aku rasa orang lain tak join lagi.
Tak apa lah. Aku cakap bahasa Inggeris tau.
Ayolah, kita malam memang BI hari ni.
Okay.
Dia asli.
Baik. Nervous je. Walaupun duduk kat rumah tak siapa nak tengok, tapi macam nervous tu lain macam.
Ya. Kita buat contoh, nanti dah lama mesti ada orang nak datang sendiri kan.
Ya. Tak apa lah. Apa jadi lah. Nak start lah?
Belum ya, aku belum start.
Okay. Ikut kau lah. Kau kat mana je Lebu?
Tak, dekat Kajang.
Oh, dah balik lah. Aku tengah hari ni balik. Balik Tampin.
Ajar. Testing. Okay, good morning everyone. So, thank you for joining. Okay, so my name is Oslat, and here we have Muhammad Azri and Haris Ali. Okay, so if everyone who want to join us can click to the link I put in the chat, so you can join. Okay, so today our topic is the usage of TypeScript. So we will talk about TypeScript, what is TypeScript, what you can share about TypeScript, and else. Okay, so I think we can introduce ourselves, and yeah, again, my name is Waslan, and Aziz and Haris can share about yourself.
Okay, let me talk first. So, my name is Muhammad Azri. I've been a software engineer for almost 5 years now. For currently, I'm working as a software engineer at Telebook Solution. My expertise is building an enterprise software application for enterprise level company. That's all from my side.
Okay, so I'm Wafid. I'm also a developer at in Imagine. So I was same to Muhammad Azri. I already 5 years working, 5 to 6 years working as a developer in the industry. And today we are here as a community in Web Sawan page. Okay, that's all. Okay, next, Haris can introduce yourself.
Okey Rafiq, boleh cakap Melayu ke?
Okay,
Apa ni, sorry tadi ada hal siap. Macam mana apa? Tengah live ke apa?
ya, tengah live.
Tengah live
Mhm.
Tengah live di Facebook ke apa?
Facebook and YouTube.
Okey, so alright. Tadi kat lain sekejap. Okey, tak apa. Korang teruskan lah.
Oh, sebelum tu boleh kenalkan dulu lah. Okay.
Oh, kenalkan dulu. Okey. Saya Haris. Haris, kenalkan apa lagi? Okey,
Kerja
kerja sendiri freelance, more kepada website, things lah, benda-benda website lah, kerja website. Contohnya website design, website hosting, domain. Okey,
Okay.
saja kan?
Okay. Okay, so basically we are hosting two type of live. So in a month we have two type of live. One is in Bahasa, and today is in English. So same like the other live will be host in other 2 weeks in Bahasa again. Okay, so I think we can start with Muhammad Aziz about what you want to share today.
Okay, sure. Thanks to the moderator, Encik Rafiq and Encik Haris, for giving me the opportunity to talk today. So, let me share my screen first.
Yeah, okay.
Okay. So, today, the topic that I would like to share is the usage of Typescript. So, before we go deeper into these technologies, we need to know what is Typescript and the purpose we integrate this into our project. So, what is Typescript? TypeScript is a language that is built on top of JavaScript, and it is actually known as a superset of JavaScript. And this technology was built and developed by Microsoft. Now, what does TypeScript allow us to do well? It allows us to add type definition to our declaration variable. Let me give you an example. Over here, we can see that the variable car at the top is assigned with the value of Azri as a string. And this is the typical way that we write in a JavaScript. But in TypeScript, this is completely valid. But what TypeScript actually allows us to do is to add type definition right after our variable name. Here we have let car, and then we add a type definition equals to Azri as a string. Essentially, what we are doing here is we're giving this car as a type of string, and the value of this variable should be a string. And this right here is what type definitions are. Why are type definitions are so valuable? Well, they are really valuable because what if in the future, during the development, for some reason, I want to use the car variable, and for some odd reason also, I assume this variable as an object because maybe I wanted to access the first name of the car, and this will be totally invalid. As you can see in the example, right here, car.firstName. This is invalid because previously we declare our car as a variable, not an object. So that's why it throws a log an error. In JavaScript, essentially what we will have to do is run our application to see whether it breaks, and then we will like, oh, something's broken, but what is it? Then we basically need to figure out that this is not an object, but it is actually a string. However, in TypeScript, because it knows the type of the name and it is a string, it will tell us right away before we compile our application again. It prompts the message telling us, hey, this is not an object, this is a string. It only can accept a string. Please fix this. And this is happening during the time we are writing our code. That being said, what are some of the benefits that we can get with TypeScript, as you might ask? Well, you can get a lot of benefits, such as catching errors early in development, and the second is serve as a documentation. As we define the types in our application with many pages and components, we might get a little confused as to what are the types that are involved for a certain prop or a certain state or whatever variable, especially if you are a new developer onto a new team, like you're onboarding to a new team. Well, the easiest thing that you can possibly do is just look at the type definition for that certain props or variable or an object, and then you will be like, okay, I can understand it. And now you have a greater understanding for what this component or application is trying to do. And the third is predictability. We know that this variable is a string because we declared the type as a string earlier. And the fourth is readability. Readability is another benefit, especially if you are working with multiple developers in one project. Let's say that you have like 15 or 30 developers working in the same project that have multiple component dashboard. If you don't have like some type definition integrated, you will have a lot of time just to understand what the object or variable holding the value is or the expected value inside. So because of the way that TypeScript is implemented and integrated with your project, your code is more self-expressive and descriptive. The downside of TypeScript is you will have more code to write. As an example, you need to create your own type definition every time you declare a new variable. The second is you have more stuff to learn, like how TypeScript is integrated with a framework that you're using with, like you want to use TypeScript in Angular or in React or in Vue. They all have different implementation on TypeScript, so you have more stuff to learn. And the required compilation, the browser, the modern browser doesn't read the TypeScript file. You need something like a compilation to convert the TS file into JS file because Chrome does not read TS file. But for the required compilation, we don't have to worry about it because when we build our application using JavaScript framework, they already have that compilation built in. Okay, so the time that TypeScript will really shine is when you're working with multiple developers in the same project that has multiple components, features, pages, and just by reading the type definition that are being used, you can see what's going on with the function or processes. So today, I will use Nextjs as a React framework that we will be using as our playground to play with TypeScript. Actually, I've already built the next project beforehand, so we don't have to wait to build it again. But I can show you the command to build our Next.js project. So when for the command to build a Next.js project is npx create next app, and then the name of our application TypeScript TypeScript playground, and then we add a flag of ts. So directly we will create a next application that support Typescript, we add the TS flag on our command, so it will automatically integrate our project with Typescript as a default. Before we go deeper into Typescript, let's talk about the benefits of Next just a little. Firstly, Next.js is supporting SSR, that is server-side rendering, meaning that it prepares the content of the page on the server instead of the client side. So means that you can in a normal React project, if you go to the page source, right, you don't see this page source on a normal React project. But if you're using the Next application, you can see all the necessary HTML tag and CSS that can help you to see what the issue is. And the second benefits of using Next is the SEO friendly. If you use the usual React framework, we cannot see the page source, but using Next, we can see that, and it helps the search engine crawler to pick up the content inside the website. And the third is easy to route page. The way that Next create a page is very easy. We just need to create a new file under a pages folder, and using that name we created. So we can directly access just by adding a URL with the file name. Let's say that this is a test.tsx, and then I'm going to use a React autocomplete for error function. So this is a test, and then I just put the test here, and it will directly go to test page. So it's very easy for Next to handle the routing configuration. That's okay. That's all about Next. Let's go back to TypeScript. In JavaScript, we have a primitive type. There is a built-in data type inside JavaScript that can also be recognized by TypeScript. There is, we have a string, we have a number, we have a boolean, and also null and undefined. Okay, so this is the basic primitive that we should have known if we're working with JavaScript, and this can also be applied to TypeScript. So the first thing that we need to know when we start learning TypeScript is type inference. Type inference is assuming the expected type of the variable throughout a program. Oops, let me type first. Type inference. Type inference, okay, let's continue. Type inference assume the expected type of the variable throughout a program based on the data type of the value initially assigned to its declaration. As an example, like the earliest, I create a new variable called car type, and we add a type definition here as a string, and the expected value that for car type is a string. So I'm adding a BMW here because that's my dream car. And for a number, num of car, we add a number here. So the expected value should be a number. And the other is boolean. So is car new boolean. So for the boolean, it should only accept two different value, that is true or false. Only these two value because it's a boolean, right? Okay, so if the type inference does not match the value type it assigned, a log will complain later to tell us to reassign to the correct type. Let's say that I update the car type, the car type as right now the correct one is a string, right? So let's say that this is Mercedes. But if I reassign it into a number, TypeScript will log a complaint here. It mentioned that type number is not assignable to a string. So you can see here it captures the log error and assists us why it is not correct, and this will make our code easy to read and maintain. So let's output this variable on our code. So we're gonna open braces here because it's a React, and then we can use a literal template because we want to add our variable inside a text. I have a name of car of, oh sorry, yeah, car type, that is. So from here I want to add a conditional statement. Let's say that if my car is new, so the statement I would like to add is new, and if it's false, and then it will be old. Oops. Let me toggle wrap this. Oops. Toggle wrap. Okay. So you can see here, this is the way that we render our value with literal template in React. So if I change this is car new to false, this will return old. Okay, so that's about it for our type inference. And then we go to the shape of an object. Typescript knows the shape of an object, like what properties it does or doesn't contain. Typescript will log an error if the code attempts to access of an object, not if it not exists. It may even suggest possible correction. So we're gonna declare a variable called first name with inference of string that holds a value of moderator in a string. And then I would like to render this value with a two uppercase, but the issue is I would like to declare this with a lowercase c. Oops, autocorrect. So look at that. It already logs an error. We can see that it shows what's the error and give the suggestion with the correct implementation. It says that property to uppercase does not exist on type string. The mean to uppercase, it already stated that C is an uppercase letter, not the lowercase. So we need to correct that, and it will render to become all uppercase. Okay, that's for the shape of an object. When a variable is declared without being assigned an initial value, TypeScript consider it to be type of any. So, so previously we learned that every time we declare a variable, we need to add a string, right? So if we just declare our variable like this, without assigning a value, this variable will become any. So it will accept multiple primitive types such as string, number, or boolean. So let's say that I want to assign, let's 10 is equal to the world. And after that, I can assign this as a number because the type for this variable is a stand. So it doesn't throw any log error because this is correct already.
So we follow the latest one.
Yes.
Um,
You follow the latest one like line by line. So if this like comes later after the word, so this will reassign the stand variable.
but how about the if we are doing array? So for example, in index one or zero, in index zero we put string, and in index one we put as numbers, for example.
Yeah, that's also possible, and I will cover that in a moment later.
Okay.
Okay, so so if we add a support annotation on the stand, we ensure that the variable can only be assigned to that type. This can be useful when declaring a variable without an initial value, like a default value. Type annotation get removed when compiled to JavaScript. The type declaration is provided by appending a variable with a colon and add the type. So you can see here, because of this stand is a type any, it can receive a value with each of which primitive type, like a string, a number, or boolean. But if we add a string here, the line number 18 will directly catch the stand because type number is not assignable to type string because we already add string type for the stand here. So the expected value of type should be a string. But if we change this stand type into a number, both of these is wrong because it is expecting a number, not a string. So let's change that. Okay, so all of the things that I have said is just a fundamental part because we have more complex concept. Okay, let's dive into that more harder part. Before that, let me create a new file just to differentiate. This is the fundamental part and the complex part. So I can create a text file and then I add a autocomplete snippet. So if you're interested to use this autocomplete, you can just go to the extension and select the first one, the first extension. Okay, so it has like 3.6 million users that use them because it really boosts your productivity. Okay, that's all. Okay, so the first complex type in TypeScript that we should have known is one-dimensional array. Okay, before that, let me go to this page, complex. Okay, okay. So the first complex type that we should have known in TypeScript is the one-dimensional array. This type annotation for one-dimensional array in TypeScript is similar to a primitive data type, except we add an array after the type inference. So as an example, let's declare a variable zip code that we assign as a type string inside the array with a value to it. As an example, okay, let me add a comment here. One-dimensional array. So let's declare a let zip codes type annotation of string, and we hold a array here is equals to the value of zip codes that I already prepared. So let's render this in our HTML, in our txtext file. So the way to call it is like you open braces, zip codes, and then we map it. We give a variable name called element. We use arrow function, and oh, sorry, it's because we're rendering an HTML inside. Okay, something's wrong. Yeah, I forgot to remove this. And then we add a div here. So whenever we try to create a looping inside our HTML, we need to add a key to this. So our key is just the same as the element. So basically key, we need to provide it as a unique ID. But right now we're just using element because every zip code is a unique to itself. So we use span and then we render the element. Okay, so this is how we render array inside React. You can see here it successfully rendered without throws and error, and all value inside is expected to be a string. But how about we push a new data but with a different type that is a number? So let's say that I add a zip codes that push because we're pushing to an array, but we add a number here, 1210. So it already logged an error that type number is not assignable to a type string because this array only expecting type string inside. So you see, Dashi already knows the issue when we push a new value, and it directly log an error when the new value is not the same type that we assign to the array. Value with a type of numbers cannot be pushed into an array with the type of string. So let's change the value type to a string. So it doesn't log an error, and this is totally correct because the value inside is a string. So what happens if I save this? This value totally will be pushed into this array and we'll update it here. See, this is successful. Okay, now that's all for one dimensional. Let's see how does the multi-dimensional works. Multi-dimensional, oops, too many typo work. Array. Then I'm gonna add some. So okay, like force this just to make this syntax cleanly. Okay. So multi-dimensional concept has a similar concept to one-dimensional, but multi-dimensional can go even further. Like the type for multi-dimensional array can be annotated by adding an extra array for each extra dimension array. So let's declare the variable of one-dimensional array. First, we'll declare let zip codes nh is equal add a string array, then it is expected to hold a value of zip codes. And then let zip codes ma, also a string of array, and it holds the value of zip codes. To create a multi-dimensional array, we create a new variable with two array annotation with an existing value of zip code, such as let zip codes. Also, basically, right. So if you don't update a new data, so it recommend to use constant to make sure that we know that okay, this data is not okay to be it's not immutable. So this is like a fixed data, so we don't want to update. But for our zip codes multi, we want to declare this array of double the array because we gonna add a multiple array inside this one array, so it become a multi-dimensional. So the first default value that we're gonna add is zip codes nh, and we also can push another array into the multi-dimensional array, like zip codes multi dot push, and then we're gonna pull zip codes ma. So this is how like it's accepting two values of zip codes here. So the way that we want to render this array in HTML, it will look a bit complex because we need to do .map method with array and in array variable. So we call our zip codes multi, we use .map, and then we open the bracket. So we need to pass two two parameters, that is element and index, but it should be inside a bracket because we have two, right? And then we add an arrow function, and then we render the tsx. So from here we add a div. Inside our div we need to put our key. I recommend to use our key as an index because we still cannot access the element inside of this. And then we're gonna do another mapping for the child element. Oops, so many autocorrect here. I hope it doesn't bothers you all. Oh, it's wrong. So dot map child element. Then we use arrow function. We're gonna call this as a HTML. We call it as a span. Because we're still mapping, this also needs to have a key. This should be CLE. And then this should be our C element here. So, okay, you see the way that it renders is like in a straight line. So this is the first array, and this is the second array. But to make it to have a better rendering view, there's a break here. So it will be each of the line will become like this. So that's how we create a multi-dimensional array in Typescript. Do you guys have any question about this concept? No? Okay.
Mm.
So we go to another concept that is tuple type. So tuple type is an array that has a fixed size of similar or a different elements type arranged in a particular sequence that is defined as a tuple in TypeScript. So the difference between array with type definition with tuple is we declare the type inference inside the array itself, and that makes it more strict on the length of the array and type of each index of the value or object inside the array. Like here is the example. So the first line is an array that the type definition outside the array, but in tuple we declare the type inside the array. So you see here, this is an array. So basically the one that we declare on the first is the same as this. But when we defining a tuple variable, let me auto toggle. So the difference between array and a tuple, we declare our type definition outside our array. But our tuple, we declare our type definition inside the array, and basically we give all the indexes its own type. So if let's say that, okay, so before that, tuple is very strict with length and order, like the length of the array and the order, like our type definition order, like string, number, boolean, and number. The way that this work is it has a fixed number of element, and hence we cannot assign a tuple with different numbers of element. Similarly, a tuple maintains a strict ordering of its element, and therefore the type for each element is enforced. A transcompiler error will be generated if any of these condition is violated. Like, let me declare a new variable, let employee, that is a tuple of string number is equals to a manager as a string, and this is null. You see, tuple enforce you to make sure that the order of the type definition expected of the value must be followed. Like this is a string and this is a number. So it means that that value should be a string and a number. Right now it's a null, so that's why it throws it logs an error. So null is not assignable to type number. So let's fix this, like 80. So that's how strict when we're using tuple type. And let's give one more example. Let, oh no, let's just use constant because we're not changing this value anymore. So constant grade, and we had a tuple of string, number, boolean. So it is expecting string, number, and boolean in our value inside the array. So the first one, we can add a Typescript as a string, 85 as a number, a boolean of true, and then somehow we add another value inside our array that the length becoming 4. So this is totally wrong because our tuple only have 3 type definition and only have 3 inside it, but we gave it 4. So you see, it already logs an error here. The source have 4 elements inside, but the target allows only 3. So basically this is wrong. The way that to fix this is just remove the last value that makes the value of the array become 3. That's all for no, no, that's all. We need to know about the tuple array assignment. Like, although a tuple may have all elements of the same type and resembles an array, like we have an array with a string, but for a tuple we declare a string inside. It's not the same. Okay, let me explain it a bit. A tuple cannot expand, while an array can. Hence, assigning an array to a tuple that matches the same type and length will generate an error. So I'm gonna add another variable, like this is a tuple. This should be constant because we're not gonna change the value inside. So our tuple is a string, January and second as a string, and our array is a new date. So if you look at this, right, and the data value inside, it's basically the same thing, like string, and this array is string outside, but basically it expected all the value inside as a string. But the thing is, event date cannot be assigned with new date because this is totally okay. Now this is wrong because okay, let's change to constant. Let because we want to update. Okay, so first it doesn't type string is not assignable to type string, the tuple type, because the targets require only 2 elements, but this source's new date is an expandable, means that our array can dynamically decrease or increase. But for tuple, we can only follow whatever the length and order of our tuple inside our type definition. So that's the reason why it's not the same thing. Okay, that's all for tuple now. I remember that Encik Rafi already asked the question, how about when we declare a type definition inside our array?
Yeah.
Does this answer your question earlier?
Um, if you know about the NoSQL, right? So
Yep.
NoSQL we can enter many data that we're not even sure what the data type is. For example, they have name, but sometimes in the name field they can have numbers, and they can have null, they can have anything. So, what should we do? Did we just change all of them to the string type, or is there any way like we can just declare it as an unknown data type, and yeah, to make it enable to join to enter the parameter.
Oh yeah, sure.
Uh,
So for this one, right? So this for if you having a property that we need to accept a multiple type definition, TypeScript already catered that use case. Okay, before we're gonna go into that, uh, because this question will be answered on the next
okay.
concept. So let me create another. Let me say first. Let me create another file that is called interface, because interface is where we're gonna do all of the custom type. definition and everything. So let me create uh, this, a new array function component, and then let me add. Okay, what's the error? Wait. Okay, so because it needs to be, yeah, uppercase, and then we add a interface. Okay, so moving on to interface. An interface is a kind of custom type or a specific structure to an object or a function that we can use in a very similar way on how we implement the custom type object. Like in the earliest example, we can add type to a single variable. And the next thing we learned previously is in array type, we want to accept all string, or we have a custom like type definition and the sequence of string number inside our array. And then for tuple, we define the type of each item following the index and the order inside the array and with its type. But using an interface, we can define the structure of the object itself, and we can add the properties and its type. So from here, we can create our interface like for a car. So interface car. So inside our car, we want to expect properties of model that is a string, a year as a number, and is new as a boolean. Boolean, yeah. And then let's declare our object inside the interface, such as car info. So the way that we want to use the car interface is the same as the inference previously. So we just call a car here, and then we want to assign the car info like with a model of BMW, my favorite car, year 2021 as a number, and is new is true. Okay, so from here we can see this object totally follows the interface car at the top. And so I render this the inside the HTML. So model open bracket car info let's access the car info object. We type model here and we close the braces. And then for the year, we call year. So you can see here, it can accept the BMW here. Cool, right? We know the purpose of our variable straight away. But remember, when we structure our object with car interface, it will demand all the properties to hold a value. Not one should miss out. But what if we create a global interface that some places are not mandatory to use year properties? So let's say that, okay, for the first question is that our car interface it is expecting model, year, and is new. But what if we miss one properties? Right now, car info will log an error because property year is missing in type model string, but it is required in our interface. So it directly log a complaint and give you suggestion what you are missing with. So year is declared, but right now it is missing. So we know directly year is missing on our car info object that we need to add this. Okay, so how about when we create a car interface that is being used as a global interface that we use on another component, but for some reason we are not using the year. So for that, we can use optional chaining. Basically, optional chaining is when we add a question mark after our properties. Naturally, it loosens up our object to allow if those properties are assigned any value or not using those properties. Let's remove the year to see what happened as an example. So it directly throws an error, right? So how about to solve this issue? So we can just add an optional chaining here, and it doesn't throw an error because of this year properties is defined as a number and undefined. So it means that it doesn't matter if we uh, add the year or not, and this will help us not to make it like less strict than previously. So this help our interface declaration to be more flexible and can be used globally with purposes. I remember that Encik Rafiq told how about like inside our type we have a multiple type for our properties. So the answer is we can just use union. Union can help us to define another type on our properties. As an example, we're still using year properties as our example. Let's say that this is a string. So you see here, it already throws an error, a log an error, because our year should be a string, a number, but right now we're giving it a value of string. But okay, so let's give a real world project situation. Sometimes like there will be some miscommunication on how they are returning the data type, like we're expecting it as a number, but the backend team they're giving us as a string for some reason, where some places for this variable is used for calculation, but some pages is used for just rendering a view. So to fix this, we just add a union type of string here. Union type is almost the same as pipe, but less one line. So this is how our year can accept two value of type definition. It can accept as a number or a string. So you see, you can accept a string and a number. And then, and okay, so when we're creating an interface type structure, we should place in its own places, like it in its own folder. Let's create one for that. So if we go to our root, right, so we create a model here, and we declare a we we create a file name called, like for an example in my cases we call it a car. So we want to import all of this interface into our car.ts file. So when we want to use this interface again, we need to put an export here so it can be used to all the project. So right now, our car definition here is basically throws an error because it doesn't find that interface. If we're using a VS Code, right, it gives you an option of a quick fix that if you click this, it will suggest you that we can find this car interface inside the model car. And we just click and it automatically import that for you. So this will help and assist us to make sure that this car interface can be used throughout all the pages, all the files that this car interface is needed. And this will help to make our code readability increase and increase productivity across all the team members inside the project. Do you have any question? And does it answer your question, Mr. Rafiq?
No. No, it's okay.
Okay, I think that's it for today. That's how that's how Typescript can bring so much value to your project in terms of clean code, like capturing error early in development, can also be used as a simple documentation to check the purpose of the object and increase readability. and more importantly, making us working in a bigger team less hard. There is still a lot of concept that I did not touch because I want to share with you guys what is the core concept of Typescript that I've been using on day-to-day basis. So if you have like any question, uh, okay, so I will give the stage back to our moderator to continue the session.
Okay, if anyone has any question, can ask in our chat form. Okay, before that, Aziz, can I know how you connect to database from the TypeScript? Is there need to use any framework or you can directly from TypeScript?
So, can you give more context because I do not understand because TypeScript uh, does not connect with
Mm,
the database.
mm,
It just and as a tools or to assist for code readability. Yes, we can use TypeScript to write inside our backend code,
mm.
but it's just a help to add a type definition on that part. because
So
because in the backend we still need to add our own type definition there.
okay, so maybe the right one is the right question is about what framework or what backend framework you can recommend for us to match with the TypeScript.
Okay, so the best framework that I can recommend, like integrating with TypeScript, is Nextjs. Okay, so Nextjs is like a copy of Angular that Nest.js took most of the complexity or core concept from the Angular with TypeScript embedded inside the project. So it makes the Nest.js more expressive when we're writing a code, and then we know what exactly the data that we're interacting with because of the type definition that we already declared inside. If you like to know more, you can Google Nest.js, Nes.js, and try to work with it with TypeScript.
Okay, someone asked a question here. What situation that made TypeScript not a good candidates of language to code?
Oh, for that, if you
Maybe you can just give
Mhm.
your
opinion, right?
opinion.
Okay, so for me, if you're working only for a small project, like a small team members, like less than three or maybe even five, if it doesn't actually giving a value to your readability, it doesn't it doesn't shine on that terms because TypeScript allow us to make all the developer connect inside one project. But if you have less team members, it does bring a less value. And one of the example is if your project is just like a small project, like a one-off project, right? Or and it doesn't scale up at some point, you will not have the benefits that TypeScript offer.
Okay,
Okay.
I hope that answer the question. Okay, next in NoSQL, oh, this seemed to my question before. Okay, another one, any VS Code plugin that you recommend for writing the TypeScript?
Again,
Any VS Code plugin that you use or you recommend in writing the TypeScript? For example, you already introduced the one that React
yeah.
plugin, right? So any idea than that, I think we can share to them.
So okay, so let me check. So the I in my cases, right, uh, I don't have the extension for TypeScript because our project itself, when we create a project application with TypeScript embedded with that, it's already integrated for capturing the error. Or if using the, what is it again? An extension such as the React autocomplete or Angular autocomplete, they already support the TypeScript. I hope this answers your question.
Okay. Okay, so we have one more from Raihan. If we imported the file from other file, does the variable will be imported too? Like we can access the variable from other file.
Come again?
If we imported the file from other file,
Mm-hmm.
does the variable will be imported too? Like we can access the variable from other file.
Yes. We can do that. But you need to put an export. Like uh, like when we create an object, right? We need to
Mhm.
put a export. Export our variable name and with our variable inside.
Okay. Okay. Next. Okay. Before that, Raihan, did you? I hope they can answer your question. Okay. So next. Okay. I think I can ask you one question. For someone who want to start learning TypeScript, what you can suggest, or maybe you can explain a little bit what the difference between the normal JavaScript and the TypeScript, and what they need to do to start their their studies, to start their, maybe you
Oh,
can say, to
mm.
start their, yeah,
Yeah, they are learning.
uh,
So,
their learning.
what I will recommend is before we jump right into TypeScript, there's a like two faction that I've read on Twitter, like
Mhm.
don't learn TypeScript, learn JavaScript first, or learn JavaScript, learn TypeScript first. But for a product that's coming from a university, right?
Yeah.
I will totally recommend learn JavaScript first because from JavaScript we learn how to use the data object or objects data object structure, right?
Mhm.
So that will help us to give more understanding on how do JavaScript work because TypeScript is just a superscript of JavaScript. TypeScript is a superscript of JavaScript, and the way that TypeScript work, it just add another features that is called type support type, and that's all. Because totally right, when we write the TypeScript, we're still writing in a JavaScript ways, so it does benefit like for both of them. So if I want to recommend which one to learn first, learn JavaScript first because the market totally rely on JavaScript first because TypeScript is giving a value of to make sure that your all the objects or variable that you declared must have a type support on it. That's my opinion. If you want to start learning, start from JavaScript first, and after that you can start to learn on TypeScript.
Okay. Good. So next from Azmi, um, can you give three words to differentiate in between of TypeScript and JavaScript? If you can say three words, what make them really differs, they are different, make them different. Can you give three words for that?
Oh, only three words.
Mm.
So okay, so the first one, predictability
Okay.
first. Second, readability.
Mm-hmm.
Oh, okay, let me explain. So predictability, I can expect what kind of value that those object will returning to. Like I can expect one inside. Readability, I can, when I first glance those object or variable, I can see what it's expecting inside it. Like what are the properties, what is the types, and how the processes work. And lastly, understanding. So from that code, in one glance, I can understand the way that the previous developer uh, implement that, and I can understand more about like the business processes using those type declaration directly. So from that, predictability, readability, and understanding. So that's how I can give you my 3 words of Typescript.
So from your answer, can I say that which TypeScript will be suitable for the team to be uh, used for the will be benefit them for the future maintenance, because it said
Yes,
that we
yes,
can improve the availability and we can make them more understandable from the normal JavaScript.
yes. Like, um, okay, so the first issue is when we're working remotely and we're working alone and we're still a new team member inside our project. I have that difficulty just to understand what are the object is expecting. So
Mhm.
rather than I run the project, I console log here and there on multiple places.
Mm.
Rather than doing that, I just go to that object or variable and see what are the type definition are attached to that variable. So if like something like called customer object, I want to see what are the properties that I can use to make sure that I can resolve or complete the business requirement that I've got. So that's about it. So the most important is TypeScript allows you to work more in the future for a long run and help you to scale with less error.
Okay. Okay. One more from Faris Azrai. Is it normal when we load our project on VS Code, TypeScript takes some time to do checking?
That's actually that's basically is about your how big is your application and how fast is your laptop. Because right now the project I've been working with is a big project, but right now my laptop is quite powerful, so it catch the errors very fast. I'm not sure how what's with your computer. I'm not sure what's the variable that's causing the TypeScript to capture the error. Yeah, sometimes it happens, sometimes not. But if I facing that issue, right, I just reload my VS Code because
Mm.
maybe there's a lot of process is happening because we download so many extension inside our VS Code,
Yeah.
and that extension are using a lot of RAM, and sometimes VS Code eats a lot of RAM compared to Google.
Mm.
Yeah, Chrome. Yeah.
Yeah, I think he focused to VS Code, so maybe he used other code editor before ESPN, that did not face anything problem on the bugs.
Mhm.
Okay, so I had many extensions. Okay, it too. Okay, so I think that's all for today. Uh, Nothing from others here. So maybe you can give your last words or last quotes to us. Anything you want to share before we close our session?
Okay. So uh, when so I would suggest you to all learn TypeScript. Uh, if you learn JavaScript, it's like a siblings. You need to learn JavaScript and TypeScript to support each other. Because right now the market outside the Malaysia, right now they're all towards TypeScript because of the value that it is bringing to the building a new project. For most of all, it's like scaling, and then the second one is working in a with multiple developers or engineers inside one application. So if you have time, give it a, give it a chance to build a project with Typescript. That's all.
Okay, so thank you, Azri. Really appreciate your sharing today. And I also want to say thank you to everyone who joined our session. And thank you also to anyone here that joined our Google Meet also. For example, Haris Salim, Nick Muhammad Aizudin, and I saw the other two, but they already left. So thank you, everyone. I think that's all for today. We will see in our next session. Thank you.
Thank you.